Back to ArcGIS Spatial Solutions. So in this tutorial, we're going to estimate the land surface albedo of a place. So we're going to use the Landsat data for this. So first of all, you have to understand what this albedo is all about, and then we can move on to the practical aspects of estimating it using the Landsat bands, right? So first of all, we have to understand what this term called albedo is about, right? So it is basically the amount of reflection of sunlight by an object of interest, right? So it is a fraction of light that is going to be reflected by a surface. So simply put, the greater the albedo value of a material is, the lesser it is going to absorb the sunlight within it. Clear? So suppose if an object of interest is going to reflect everything that is going to fall on it, right? Suppose if it is going to reflect all the incident sunlight that is going to fall on it, it is going to be having a value of 1, which is mostly unlikely because there is no object that is going to fully absorb or fully reflect all the incident wavelength, right? So this albedo is measured between 0 and 1, right? So the 0 indicates the complete absorption of all the incident light, and 1 indicates the complete reflection of all the incident light. So all the objects in our planet is going to be varying between 0 and 1, right? So here is a small example where I've given a surface which is going to reflect 30% of the sunlight that is going to be incident on it. So they're getting a value of 0.3 here, right? So 0.3 indicates that it is going to reflect off 30% of the incident light, and it is going to then absorb the remaining 70% of the incident light, right? So that is a broad overview of this albedo concept. So as you can see, each surface, each object in our planet is going to have a different albedo value, right? Based on its surface characteristics, right? So as you can see, the fresh snow is going to be having a larger albedo value as compared to the rest of the objects because of its whiter color, right? So as we all know, the whiter color will always reflect a lot of incident energy, right? As compared to the black color, which is going to absorb everything that is going to fall on it, right? So keeping that in mind, you can see that each object of our planet is going to have a different albedo value based on its surface characteristics, right? So we can see how to calculate this based on the Landsat bands, which have already from the USGS website. So as you can see, we have so I've given two options out here. So the first option is, if you're going to have this Landsat 7 data, right, then you have to consider these bands of interest for your estimation, right? So ultimately we're going to use only the blue, red, NIR and the short wave infrared bands of 1 and 2 for satellite sensors, right? So it is going to be these bands which you have to consider to estimate based upon your sensor, right? So if you're going to use this Landsat 8 data set, then you have to consider the bands 2, 4, 5, 6, 7, and for 7 you have to consider the bands 1, 3, 4, 5 and 7 to estimate the albedo of a surface. Clear? So we can go to the calculation process now, right? So firstly you have to consider the Landsat DN values, right? So more importantly, you have to download the Landsat level 1 data product from the USGS website, right? So it is not the level 2 which you are going to work on here, it is going to be level 1. Download the level 1 product, and then you have to convert the level 1 product to the top of atmosphere reflectance values, right? So for that you have to apply this formula out here, right? As you can see, it is going to be this formula which you are going to use, right? So you can see these values. So we're going to obtain these values from the MTL file of our sensor data product, right? So let me show you later on about that, right? So you have to just keep this formula in mind. So it is going to be so we're going to obtaining these values, right? These M, A and the SE value from the MTL text file, right? And obviously this Q represents the raster band which you're going to multiply, right, with these values, right? So after converting this into the top of atmosphere reflectance data, we have to convert this top of atmosphere to the albedo surface, right? So for that you have to apply this formula, right? So these are the coefficients which you have already obtained, right? So just have to multiply bands with the appropriate coefficients to get the final product, right? So since I've used the Landsat 8 product out here, I've used the bands 2, 4, 5, 6 and 7 out here to get my final albedo surface product. You can see I've added the bands of interest out here, So I'm going to use my Landsat data product here. So I've added all the bands 2, 4, 5, 6 and 7 here. So this place of interest is the Salem city of Tamil Nadu state of India. So I'm going to compute the albedo for this place of interest. So firstly I have to open my MTL text file to get to know the coefficient values, right? So which I've already done out here. So you can see this is the MTL text file, right? So we have to use some of these coefficients for computing our top of atmosphere reflectance value firstly, right? So for that you have to go to the raster calculator option to use the formula out here, right? So firstly I have to go back to the PPT to search for my first value, right? So the first value is representing my reflectance multi-band value, right? So you have to search for this term in the MTL text file. So it is going to be somewhere here, right? So as you can see, it is the same value for all the bands, right? So it is going to be very easy for you to compute the final product, right? So it is going to be the same value. So you can see I'm going to carry, so it is going to band 2, so it is going to be 2 into 10 to the power of minus 5, which is going to equal 0.00002, right? So I have to use this value in my raster calculator. Then secondly I have to go back to the PPT to check my A value, that is going to be my reflectance add band value, right? So it is going to be this one. So it is going to be obviously minus 0.1 for all the bands. So I have to use these two values in my raster calculator now. So let me go back to the raster calculator. So it is going to be 0.00, right, 2, right, multiplied by my band raster, it is B2, right? Followed by this I have to use my reflectance add band value. So my reflectance add band value was in a negative, right? So it is going to be plus into minus minus, so it is going to be minus my reflectance add band value. It is going to be, so let me copy this and paste it out here. So it has been pasted, so you can see. So finally I have to use my sun elevation angle, right? So it is going to be my sun elevation angle, that is divided by this term. So it is followed by this, divided by this, followed by this. I have to use my sine. So it is out here. So it is sine of my sun elevation angle is what I have to search for in my MTL text file. As you can see, it is going to be on top of the notepad. So you can see it is going to be somewhere out here. You can also use this find to search for it. So you can see, fine. So you can see this value out here. So, it is going to be my sun elevation value. So the important thing to consider here is that it is the degrees format. This value, have to convert this value into the radians format for us to enter this value in the map algebra tool. So firstly I have to copy this thing, go to my search engine to convert this value from degrees to radians. So it is going to be, so I have to use some tool to convert it. So it is going to be degree to radians too. So I have to copy that value, which so I have to paste this value out here. So it is going to be, this is the radian, it is going to be my radian value. So I have to just copy this thing and then paste it in my map algebra tool. So it is going to be sine of this value, right? So everything is done. So we can just save this thing in an appropriate folder. So let me save it in a folder of interest. So it was inside my, let me name it as DOA reflectance. So you can save this inside this folder as b2doa.diff, right? So I have to just repeat the same process for all the rest of the bands by just changing the band name out here, because it is going to be the same value for all the rest of the bands. So it is going to be very simple. As you can see, it has given me the value for this band 2, so I have to repeat the same process for the rest of the bands as well. As you can see, I have computed the top of atmosphere reflectance values for the rest of the bands as well. Move on to the final step of albedo estimation. So for that I have to open my raster calculator again. So I have to use my second formula now. So it is going to be this formula, right? So I just have to multiply all the corresponding bands with their corresponding coefficients to find out my final product of albedo. So you can go back to this raster calculator tool to do that. So it is going to be the formula, right? So firstly let me open a pair of parentheses out here. So first it is going to be 3.8 356 multiplied by band 2, right? So followed by this I have to add this thing with my second band along with its coefficient. So it is going to be again a pair of parentheses. So it is 0.130 multiplied by band 4 top of atmosphere reflectance data. So it is B4 TOE. So it is multiplied. So it is again I have to add this thing. So it is added by again a pair of parentheses. So it is going to be 0.373 coefficient value multiplied by band 5 followed by this added by this again, that is going to be again a pair of parentheses. So it is 0.085. Alright, so 0.085 multiplied by band 6 TOE added by final one. So it is 0.072 for band 7. 0.072 multiplied by band 7's TOA. Right. So finally I have to subtract this entire thing. So it is going to be subtracted by this coefficient 0.0018. Right. So finally I have to encompass the entire numerator with a single pair of parentheses, so that it is going to be divided by the denominator later on. So it is going to be divided by 1.016, which is going to be the sum of all the coefficients which I have added out here. Right. So it is going to be the sum of all the coefficients out here. So we have done this thing. So you can just save this thing in a folder. So it is going to be named as Albedo for Salem. So it is Salem Albedo .tif. That's it. You can save this thing to get our final product. So I've just given it a suitable color palette so that the lower albedo values are having a red color and the higher albedo values are having a blue color. And I've also added the base map layer to emphasis on certain places. As you can see that these places of interest are most likely the suburbs of our city, right? So it is far away from the commercial business district. So this place happens to be the proper Salem city. So it is well away from the CBD. So you can see that it has got a very good albedo value as compared to the central places. And also you can see some good albedo values out here because these places are comprised of some dense vegetation areas, right? So it is going to reflect off a lot of energy that is going to fall on it. So in this manner you can just do some good insights to get some good insights on various study area. Right. So I hope this video was of some use to you. So please subscribe to my channel for more interesting contents like these. Thank you so much for watching.